Hi everyone, we're going to write an exponential function for a graph that passes through given points. I have 4 problems here, and we're going to write the equation as y equals a times b to the x power. And if you recall, if we're going to look at the y-intercept, if I have b to the 0, you know that equals 1. So if I'm doing a graph, or doing a table of values rather, and I want to know what the y-intercept is, I let x be 0. Now if I let x be 0, that means my y-intercept is going to be a, because you're going to have y equals a times 1 because of your letting your x be 0. And that's the key point to remember, and the rest is substitution. So the 4 problems I'm going to do are basic ones. We're going to do 0, -2, and that's Boolean algebra for and, -2, -32. I'm also going to do this one, 0, 3, and 1, 15. And the other 2 are 0, 7, and 2, 63. And the last one is going to be 0, -5, and -3, -135. Okay, if you notice before we get started that the left side here, these are all your y-intercepts. So basically, for the first one, if I plug in 0, my y-intercept is going to be -2. And I plug in 0, my y-intercept is going to be 3. And I'm doing this is your number 1, your number 2, your number 3, and your number 4. So basically, these are your A's. And then we're going to plug in the other point to find the B. Okay, so let's get started with the first one. The first one we have is 0, -2, and -2, -32. And I want to write an exponential function of this form. Okay, so my A is going to be -2. So I'm just plugging in my A. Now I'm going to use the other point to plug in my X and my Y. So my Y is -32. And my X is -2. Now, the first thing I'm going to do is divide both sides by -2. So I get 16 equals B to -2. Now, you can, what I'm going to do, you can do it either way, any way you want, but this is what I'm going to be doing on this. To solve for B, I'm just going to power this by -1/2. What happens on this side is that equals 1, so we just get B to the first power because we're solving for B. On this side, I get 16 to the -1/2. Now remember, the negative, that's the inverse exponential identity, so that's really going to be, 1 over 16 to the 1/2. And we're going to go ahead and put it in radical form. You don't have to, but that's like saying 1 over square root of 16 equals B. So 1 over 4 equals B. Now, I'm just going to plug in my B back into this equation here, and I'm going to get y equals -2 times 1/4 to the x. So now I have my exponential equation. And if you recall, this is not growth or decay, because my a has to be greater than, my a has to be positive. The next one we're going to do is 0, 3 and 1, 15. So I'm going to write y equals a times b to the x. My a is my 3 here. Now substitute in the other point. My y is 15. And my x is 1. Divide both sides by 3, and we get 5 equals b. So I'm just going to plug this back in to this b. And I got y equals 3 times 5 to the x. This would be exponential growth. The next one, we have 0, 7 and 2, 63. My y-intercept is 7. You plug in your other point. Okay, now we're going to divide both sides by 7, so you get 9 equals b squared. Now you can square root both sides if you want. What I like to do is, okay, we'll just square root this one. It's a little easier. Square root both sides. You're going to get 3 equals b. So our answer, since this is our b, I'm going to write y equals 7 times 3 to the x. And I have one more. And this one is 0, -5 and -3, -135. So I'm going to write in my y-intercept from the first equation and then plug in my second equation. To solve for b. Alright, so I'm going to divide both sides by -5 and I get 27. In this case, I'm going to go ahead and just power everything by -1/3. This cancels out because -3 times 1/3 is just 1. And this is like saying 1, this part here is 1 over 27 to the 1/3, which is the same as 1 over cube root of 27. Cube root of 27 is 3, so b equals 1/3. So my equation now is y, I'm going to go back to this, and that's all. Thank you and have a nice day. Bye-bye.